When live loads are in tandem, the procedure of taking the moment using Courbon'S method changes. Check this second example here in bridge engineering. The next bridge is 24 meters long, with 4 girders spaced at 2 meters. Two wheel loads crosses the bridge. The first is 80 kilonewtons and the other is 40, and they are spaced at 4 meters. The load line occurs 2 meters to the right of the center line, and we are to figure out the maximum midspan moment in girder D. The longitudinal section shows the bridge's length of 24 meters. The cross-section, on the other hand, consists of the 4 girders A to D, which are spaced at 2 meters. With a center line, girder A then is at -3, girder B is at -1, girder C is +1, and girder D is at +3. The wheel loads are at 2 meters to the right of the center line. Let's tackle the influence line first. Since we are looking for the maximum moment at midspan, the wheel loads will be located at the midspan, and the heavier load is exactly at the midspan. We are to separate the two loads when identifying the influence line ordinates. Starting with the 80 kilonewton load, which is placed exactly at midspan, we can take the influence line ordinate by using L all over 4. And in this case, it is 24 over 4, or that is 6 meters. Alternatively, there is a general formula for influence line ordinates, which is x by the length minus x all upon the length. L is the full length of the bridge, and x is the distance of the applied load from the left support. If we try to use this, we take x of 12 multiplied by 24 minus 12, then divide everything by 24. This also gives 6 meters, which is the same with the first approach. For the second load of 40 kilonewtons, supposing that it is located ahead of the 80 kilonewton load, the influence line ordinate then is solved as 16 times the difference of 24 and 16. Then divide this by 24, which provides 5.33 meters. You will still have the same answer when we locate the load at the left of the midspan. Here is the deviation of procedure from the first example. Learning the influence line ordinates, we compute for the moment by taking the summation of each load. The moment then is 80 kilonewtons by 6 meters plus 40 kilonewtons with 5.33 meters, which gives 693.2 kilonewton meter. This is the total moment, which needs to be distributed across the girders, and that is where we have to use Courbon method. We take the summation of load, that is 80 plus 40, giving 120 kilonewtons. N is 4, and E is 2 meters. The summation of the squares of x distances is then computed as the square of -3, with the square of -1, then the square of 1, and the square of +3. This results to 20 square meters. Also, the distance of girder D from the center line is 3 meters. Completing all the parameters, we compute for the reaction at girder D as 120 kilonewtons upon 4 multiplied by 1 plus 6 times 2 meters by 3 meters all over 20 square meters. This gives 84 kilonewtons. This means that from the total load of 120 kilonewtons, girder D carries 84 kilonewtons. So take the distribution factor. That is 84 kilonewtons over 120 kilonewtons, giving 0.7. This means girder D carries 70% of the total load. From the total moment we computed earlier as 693 kilonewton-meter and a distribution factor of 70%, the final moment of girder D is then taken as 70% of 693.2, and that is 485.2 kilonewton-meter. With the same problem, try solving the moment carried by girder C. If done right, you are to come up with M of girder C as 277.3 kilonewton-meter. Good luck!